A small band of woolly mammoths was still walking the Earth while humans were building the Great Pyramids of Giza. Most of their species vanished 10,000 years ago, but these survivors persisted long after the Ice Age ended. This timeline shows a 6,000-year gap between the extinction of the mainland populations and the final stand on Wrangel Island in the Arctic Ocean. These mammoths remained until just 4,000 years ago. Wrangel Island was a nearly perfect refuge. Intense Arctic winds prevented forests from spreading, maintaining the open tundra habitat the mammoths required. Large predators were absent, and humans had not yet reached its shores. This untouched paradise provided every external resource a population needs to thrive. Yet, even without predators or climate shifts, the group still disappeared. Evidence for their sudden collapse is preserved inside the enamel ridges of a single fossilized molar. In 2015, researchers sequenced the DNA from a tooth belonging to a mammoth that lived on the island 4,300 years ago. This side-by-side comparison with a 45,000-year-old mainland mammoth reveals a stark biological decline. The island genome is full of missing sequences, broken genes, and strange mutations. This DNA reveals a process known as a mutational meltdown. For highly isolated species, the ultimate threat is an internal biological failure triggered by their own genetic code. Rising sea levels at the end of the Pleistocene epoch melted ice shelves and swallowed the land bridge to Siberia. This physically trapped the mammoths on a shrinking island. This trapping effect occurred elsewhere. On St. Paul Island, Alaska, a separate group survived until 5,600 years ago, only vanishing when their freshwater sources became too dry. On Wrangel Island, the surviving population consisted of only a few hundred individuals. Conservation biology uses specific thresholds to determine if a species can survive. A population needs at least 500 individuals to maintain genetic diversity, and 1,000 to prevent the accumulation of harmful mutations. Wrangel Island's small geography restricted the population to just a few hundred mammoths. As this metric shows, they remained permanently below the 500 individual threshold. When populations cannot grow and new adults cannot migrate in, natural selection fails. Random, damaging genetic errors eventually become fixed in the gene pool. These genetic errors altered the physical traits of the mammoths, starting with a mutation in the FOXQ1 gene, which is responsible for hair development. This diagram contrasts the healthy, coarse guard hairs of a mainland mammoth with the mutated coat of the island survivors. Their hair became shiny, silky, and translucent, which destroyed its ability to shed snow and stay warm in Arctic winds. Other mutations led to invisible but severe biological costs, including reduced male fertility and even significant developmental defects. They even lost the olfactory receptors required to smell flowers, a trait encoded in the decaying DNA. This population reached a state of quiet biological decay. They became functionally broken versions of themselves, failing the mathematical requirements for survival. The genetic mechanisms that doomed the Wrangel Island mammoths are appearing in several modern species today. Human infrastructure, highways, agriculture, and urban sprawl traps animals on isolated islands of habitat, mimicking the rising sea levels of the Ice Age. Modern cheetahs are currently struggling with severe genetic bottlenecks and low diversity, resulting from habitat fragmentation. Gorillas face similar pressures as they are increasingly confined to shrinking patches of forest, preventing the migration needed to maintain a healthy gene pool. Sea otters also show signs of high vulnerability. Although their numbers are recovering, their genetic diversity remains dangerously low due to past isolation. The autopsy of the last woolly mammoths is a warning for the future. Saving a species requires more than just a patch of land. It requires habitat connectivity to ensure genetic diversity and prevent the ghost in the genome from appearing again.